Hi everybody. So today we are going to do refraction through a glass prism. So before I start, let us do some recapitulation of last class. So we are done with reflection, and then we are done with refraction through we define our refractions, we define our laws of refractions, and then we define a refraction through glass slabs. And then we talk about refraction through lens, a spherical surface, refraction through a lens, and we derive two important formulae, that is lens maker formula and a thin lens formula. And then we are done with some optical phenomena such as such as total internal reflections, the application of total internal reflections. Alright. So today what we are going to do is a last refraction, that is refraction through glass prisms. Alright. So let us, before I do refraction through our prisms, let me differentiate what exactly prisms look like and how prism vary from glass slab. Alright, so let me start. So when we talk about glass slab, this is the glass slab, and this could be a glass slab. So what you need to know is, whenever we talk about glass slabs, the two sides has to incline in the same directions, either vertically or inclined. So this is what we talk about glass slab. Alright. Now when we talk about prisms, right? When you talk about prisms, the only difference between a prism and a glass slab is, when we talk about prisms, two sides of a glass are inclined in opposite direction. This is what we have. Two sides are inclined in opposite directions. So this is what we talk about the prisms. So prism has what we call as angle of prisms, and maybe normally we use a 60 degree, and for glass slab, angle of prism is going to be 0. Angle of prism is going to be 0. Why? Because they two are parallel. So this is how we differentiate prism from glass slab. So I'll give you this example. This is the prism. Alright? Look at here, this face and other face are inclined in a opposite direction. And that make an angle, and this angle is what we call as angle of prism. Alright? So now today what we are going to do is, we are going to do refraction of light through prism. And whenever we talk about refraction of light, we should keep in mind a Snell's law. Alright, so let me do a small recapitulation of the Snell's law. Sin I divided by sin R is equal to n to 1. Alright, which is equal to refractive index of second medium divided by refractive index of first. This is what we define as Snell's law. Alright, so now let me explain you refraction of light through glass prism. So this is a glass prism, right? This is how I put, right? This is a glass prism, right? So I'm going to send a light in this way, and light comes out from that way. So look at here. First, let me explain a ray diagram. Alright, so this is going to be a incident ray. Alright, incident ray falls on a surface AB, alright, with angle of incidence I at surface AB. So this is going to be angle of incidence, right? And then I say this ray undergo our refractions. This ray undergo our refractions. So this is a normal line. This is a normal line. And since this is refractive index, ear medium, this is refractive index over glass mediums. So glass is a denser, ear is a rarer. Bending is towards normal. So what exactly we have done? Bending is towards normals. And now this is a refractive ray. QR is a refractive ray. QR is refracted ray. QR is a refracted ray. Now look at here. R1 is angle of refraction. R1 is angle of refractions. Angle of refractions of surface. Which surface? First surface, that is AB. And then now QR incident on a second surface. QR incident on a second surface, that is AC, and angle of incidence is going to be R2. So I just say R2 is angle of incidence. Angle of incidence for surface AC. Surface AC. All right, and this is a normal line. This is a normal line. This is a normal line. This is normal line. This is also normal line. All right, and this is angle of incidence. And then QR is an emerging ray. QR is an emerging ray. RS is an emerging ray. Now again, if I say this is the extended, and again this is bending away from normals. All right, this is bending away from normals. Why? Because when the light goes from denser medium to rarer medium, bending is away from normals. You see, it is bending away from normal. All right. So now look at here. At one surface, look at I just say E is angle of emergence. Angle of emergence. Angle of emergence. E is angle of emergence. Now look at here. Side AB offers a bending towards normals, and side AC offers bending away from normals. Right? Look at here. This is towards normal. So now look at the bending is along the same directions. Look at here. Bending is towards same directions, right? So therefore what we have is what we call angle of deviations. What we call angle of deviations. Angle of deviations. So angle of deviation is angle formed between extended incident ray, that is PN, and extended emerging ray, that is SN. So this is what we call angle of deviation, total angle of, that means I'm going to add up these two. Let's say this is number 1, this is number 2. If I just add up number 1 and number 2, we will get total deviations. This much deviations occurs in our first surface, this much deviation occurs in our second surface, and this is how is 1 plus 2. This is what we have. Alright, so now what we are going to do is we are going to find out the relations, right? And we will use the Snell's law to get, right? So what we are going to do is we will find out the relation between angle of prisms, this is angle of prisms, and then deviations, alright, and refractive index. This is how we are going to do. Alright, so to start with, let's say alright, so I say ABC is a prisms. ABC is a prisms. I just say ABC is a prisms. ABC is a prisms. And now what I'm going to do is I'm going to take these quadrilaterals. Alright, I'm going to take quadrilaterals. Look at say, let us take a quadrilaterals. Let us take a quadrilateral A, Q, and R. I'm going to take these quadrilaterals. Our focus is to find out angle of incidence and angle of refractions. That is what is our main focus, right? So I take these quadrilaterals. Once I take these quadrilaterals, I say that this angle at the vertices, right? So I just say angle at Q and angle at R in this in quadrilateral A, Q and R is, let's say, 90 degrees. These two are 90. Why? Because these two are normal. These two are normal, right? This is normals. Alright. This is also a normal. Alright, therefore these two angles are 90 degree. Therefore, we know that the sum of all the angles of quadrilateral is 360 degree. So therefore, these two angles, right? Therefore, I just write, therefore, angle A plus angle Q and R must be equal to 180 degree. This is equation number 1. This is equation number 1. Now equation number 2 is, I just take a triangle. Let's say I take a triangle. I take these two triangles, right? A by Q and R. If I take a triangle Q and R, we know that the sum of three triangles, sum of three angles of a triangle is 180 degree. So therefore, I just say angle R1 plus angle R2 plus angle Q and R must be equal to 180 degree. Let's say this is equation number 2. Alright, now look at here. This is 180 degree. This is 180 degree. If I say compare equation 1 and equation 2, compare 1 and 2. What we get is these two cancel out, Q and cancel out. Angle A is equal to angle R1 plus angle R2. This is what we have. So therefore, angle A is equal to angle R1 plus angle R2. This is what we proved. Alright. Now what I'm going to do is, I will find out what is the total durations. What is the total duration? Just now I told you the total duration is equal to angle 1 plus angle 2. So we say the total duration is how much? Total duration is what we call as angle 1 plus angle 2. And how much is angle 1? Angle 1 is equal to I minus R1. Look at here, this is I. Vertical opposite angle, alright, and I minus R1 is angle 1. So therefore angle I minus R1 is angle 1. What about angle 2? Angle E minus R2 is angle 2. Look at here. Angle E minus angle R is what we call angle 2. So angle E minus angle R2 is 2. So therefore, I plus E equal to minus R1 plus R2. This is what we call deviations. This is total deviations. I hope this is equation number 4. Alright. Now look at here. Now I'm going to choose one conditions. Alright. Looking at this angle of deviations, and I say that R1 plus R2 is A. So I reduce this. Let's say I will not put equation of 4. I1 plus minus A is equation number 4. Now look at here. This is what we have. This tells us the relation between angle of deviation and angle of incidence. So angle of deviation depend on angle of incidence. This equation tells us how angle of incidence depends on angle of deviation. And then when we do a plot, when we plot a graph, we'll be getting this curve we are going to get. This curve we are going to get. When we plot a graph between angle of deviation and angle of, when we plot a graph between angle of deviation and angle of incidence, we are going to get this. Alright. Now if I explain you this graph, and this graph is a curve like this. Alright. So angle of incidence increases, then angle of deviation decreases, and you just get a point where you find a minimum deviations. This is what we call as minimum deviations. So at particular angle of incidence, the deviation become minimum, and if you further increase angle of incidence, again deviation increases. So when you look at the graphs, only at a particular angle of incidence, alright, you get minimum deviation. All other particular deviations corresponding to two angle of incidence, like this, two angle of incidence. I have a two angle of incidence corresponding to one angle of deviations. However, for minimum deviation, so minimum deviation corresponding to only particular angle of incidence. Alright, so this is how we get it when we plot a graph. This is what we have in our practical also. You are going to do this. Alright, so the condition for these minimum deviations is such. So I said at minimum deviations, at deviation is equal to minimums. Alright, then we say that refractive ray QR is parallel to a base BC. This is the conditions. Alright. So for this is equal to this, then angle of incidence must be equal to angle of emergence. Angle of incidence must be equal to angle of emergence, and R1 must be equal to R2. This is the conditions. Alright. So this is for minimum deviation, not for all the deviations. For minimum deviations, the refractive ray is parallel to the base of prisms, and angle of incidence is equal to angle of emergence, then R1 is equal to R2. Alright. Therefore, look here. Therefore, we know that A is equal to R1 plus R2. Since R1 is equal to R2, A is equal to R2R. Therefore, R is equal to A by 2. This is one, and this is how we found angle of refractions, keeping a condition that is minimum deviations. And now look at here. Now for this is equal to GM. Alright. I is equal to E, that is equal to I is equal to E, alright, plus minus A, alright. So therefore, what is A? And then GM is equal to 2I minus A, and then I is equal to GM plus A divided by 2. This is what we have for angle of refractions, angle of incidence. Now we found both angle of incidence and angle of refractions. We found both angle of incidence and angle of refractions. Now I am going to substitute this in a Snell's law. So we have a Snell's law. Look at here. I have this N2 divided by N1. Alright. So therefore, this is what we call as N21. So N21 is equal to, what is I? I is equal to Dn plus A divided by 2. What about R? R is equal to A by 2. This is what we have. Now again I'm going to bring one conditions, right? So for small angle of incidence and for a thin prism, right? For thin prisms, A is very small. So condition I is very small, and if prism is very thin, obviously A is going to be very small. Then it's going to be dm plus A divided by 2 divided by sine A divided by 2. I'm sorry, no sine A. These two cancel out. We will get n21 is equal to dn divided by A plus 1. Alright. Okay. So now this is equal to 1 goes this side. So dn divided by A is equal to n21 minus 1, and then finally we get minus 1 A. So this is the relations. This is the relation between angle of minimum deviations and angle of prism, angle of minimum deviations and angle of prism and the refractive index. And again, this is not valid, or this is not true for all the prisms. The condition has to be this. For small angle of incidence and for thin prisms, this is true. Why? Because we took these conditions. Alright? Why? Because we say that sine small, just remind you, if sine theta is small, it is almost equal to tan theta, which is almost equal to theta. For small theta. Alright, so this is a refraction of light through prisms. This is refraction of light through prisms. Alright, so things are very clear here. Alright, so look at here. Whenever we talk about this is one particular angle, right? So therefore, you can see that angle of minimum deviation is also a characteristic of an prisms. Alright, and that's why it was provided if A is fixed. Why? Because n21 is a refractive index which defined a minimum deviations if A is fixed. Alright, and again, angle of minimum deviation is also affected by angle of prism. So therefore I say that these three terms are the property of prisms. Angle of prisms, refractive index, and angle minimum deviations. Alright.